Hi, welcome to MagLift, our project, which is a magnetic weight training machine, which instead of using conventional weights and gravity, we kind of have a magnetic particle brake providing the resistance. So let me just explain the major components. Here you have the actual magnetic particle brake, which is attached to a shaft, which is in turn attached to a spool, which is attached to a rope, and the spool kind of converts the translatory motion of the user to a rotatory motion. Also attached is a retractor, which brings it back to the initial position once the user is done with his motion. We also have the controller for the brake, which converts an input from the Arduino to the actual input to the brake and also supplies power to it. Here is our Arduino itself, and we have a user interface through displays, a dial and two buttons. So let's start powering this up, and what you see is a welcome screen. Hello, welcome to MagLift, CU 2014 Expo. First thing we do is we select a desired weight. It goes from all the way from 2 pounds to 60 pounds, which was our initial desired weight. And so let's start with a nice and easy 15 pounds. Then we press 2 to continue. We have 3 workout profiles. One is flat. The second one is ramp up, which increases from the initial to the final by 44%. And lastly is a hill, which has a peak in the middle of your motion. And what this actually involves doing is kind of calibrating each and every component of the system, starting from the voltage that the brake needs to take to deliver a particular braking torque, to the amount of retraction force that the retractor actually provides, which actually increases as you pull further along because it's based on a spring. And also the spool itself, which has a wound up rope around it, which and the moment arm for that spool kind of decreases as you pull because the rope unwinds. So taking into account all of that and building a highly involved MATLAB model, and all that boils down to is a single value that the Arduino outputs, that the brake takes, and gives the user a very smooth and nice motion. So let's start off with a nice and easy flat motion. I'll ask you to look at the voltage output, the voltage input that's going into the brake, and as you see, as I pull, it'll actually fall off to account for the calibration specifically of the spool and the retractor. And I shall press 2 to continue on the screen, and it'll take me to the actual screen, which displays 2 essential things. One is the weight, and the second is the rep count, which we can reset using button number 1. So going back to the voltmeter, and I'll show you. So the logic is essentially the user pulls, he stops, which disengages the brake, and we release, it goes back to the initial position, it engages again, and then the user pulls, we stop, it releases, and then we disengage, and then we engage again once it comes back to the initial position. You can see that the rep count has gone to 2, and then pressing this number 1 button, we bring it back to 0. Let's try something new. We go back to the home screen, we press 2 to continue again at 15 pounds, and then let's try a ramp up. And I would again request you to look at the needle right there. It'll increase slightly as I pull. Pull, stop. And then I shall repeat this for you. I think we can get a smoother action than we actually eventually got. One second, let me just go back home screen. 2 to continue. Let's do a hill setting, nice and easy. And then once I go back, and then I'll just go back to the ramp up. Let's do it a nice and easy 7 pounds. Much easier. Alright. So pull, it slightly increases, stop, tracks back, goes smoothly, and then pull again, increases slightly, tracks back, goes again. Nice and easy. As you can see, the voltage needle moves up slightly as you pull along. So the logic behind this is based in a big part on the tachometer here, which tells you whether the shaft is rotating clockwise or counterclockwise, and also tells us how many degrees the shaft is rotating by essentially having the Hall effect sensor pinged every time a magnet goes by. So as you pull, we know that more degrees have passed by. We kind of account for the decrease in the moment as well as the increased force of the retraction mechanism. And now let me show you my favorite part, which is the hill setting and our last mode, which is quite fun. And then now we're in the hill setting, and then I request you to look at the needle again. So it'll go up slightly and it'll come back down. Oh, slightly drop, then goes back to 0. And then go slightly up, and then goes back to 0. So that, in a sense, was our project. Hope you enjoyed that video, and thank you so much. And we